Okay, welcome to the quick little tutorial here on the powers, the exponent rules. Things you've seen before, but just a quick little refresher on this because we're going to be getting into exponents and logs in this particular unit. So let's take a look at some of the things that make these tick, starting with the exponent rules. And the first one's really easy to do. It's the product of powers rule. If you have two things that have the same base, and I'm going to use that word base a lot in this unit to refer to the number that's being raised to a power, or the variable that's being raised to a power. In this case, for the product of powers, the base is a. So I could substitute an x or a y or any other number in there, and that's going to give me my base. So, quick little example on this one. If I had x to the third, and I was multiplying that by x to the fourth, then my result would just be x to the seventh power. That's because I have 3 x's and then I add on another 4 x's, then I'm multiplying. So they're all getting multiplied together. Quotient rule, pretty straightforward to do. You just subtract the two exponents. So if I had y to the 8th over y to the 5th, that would end up being y cubed, or y to the third. And then the power of a power rule is kind of fun because you get to distribute this exponent here into everything that's inside. And if you look down to the next line, the power of a product, that's pretty much what you do. You take this exponent and you send it into each of the two things that's inside there. Same with the quotient rule. They're all pretty well related to each other, so I'll do just some quick examples. If I had x to the fourth, and then I raise that to the fifth power, then that means I have 5 x to the fourths, and I'm multiplying together. And that's going to give me a total of 20 powers of x when it's all said and done. With the power of a product, maybe I have 2 things inside the parentheses or more, and if it's more, then you'll send the exponent into each one. So if I had, for example, 2x squared y, and I was raising it to the third power, then pretty much what I would be doing is taking this exponent of 3 and sending it into each and every one of those bases. So taking it a piece at a time, you're going to have 2 to the third, which is 8. You're going to have x squared to the third, so that's going to give me x to the sixth. And then you're going to have y to the third, which is just going to give me y cubed. So 8x sixth y cubed is what we're looking at for an answer there. Quotient rule kind of works pretty similar. I'm going to use real numbers in this case, though, honest to gosh numbers. So if I had, I don't know, let's just say a fraction like 2/3 and raising it to the fourth power. Well, 2 to the fourth would be 16, and 3 to the fourth would be 81. So you would have 16 over 81 is the simplified version there. Okay, now my next rule here is probably my favorite. I love this rule because I have a kind of a strange explanation for it, but it'll make a whole lot of sense. That rule is on negative exponents. And when you have a negative exponent, it's pretty much the misbehaving child of mathematics. That's what I call it, because they're kind of like pretty rotten to deal with sometimes. And those of you with younger siblings who misbehave, you understand. So this a to the n here, or a to the negative n, means we're just going to do a reciprocal. So to kind of give you the misbehaving children explanation, if you had something that was in a denominator, a numerator rather, so like an x to the negative third, and that was in a numerator of a fraction. Well, that child is upstairs and misbehaving, you see. The child is upstairs, has a negative attitude, and is misbehaving. So in order to get you to have the child behave, you call it down by its first, middle, and last name so the child knows that they're in trouble. And they come downstairs and they lose their negative attitude, so it becomes 1 over x to the third. And then on the other end of things, if you already have a misbehaving child downstairs, for example, 1 over y to the negative 6th, well, if the child is misbehaving and already downstairs, then what you're going to do is likely send them to their room. So you say, go to your room, use all 3 names. So the child goes upstairs and decides not to push his or her luck any further, drops the negative attitude, y to the 6th over 1. So that's the cheap and very silly explanation about negative exponents being the misbehaving children of mathematics, because, yeah, that kind of happens from time to time. Okay, quick little reminder on zero exponents, and that's kind of easy to work on. I can do a quick little proof if you want me to in class as to why this is the case. But the shortened version is anything that you raise to the 0 power, anything at all that you raise to the 0 power, so long as itself isn't 0, that's going to work out to be 1. So if I were to take even like 184 and raise it to the 0 power, I'd come back with 1. So assuming that your base isn't 0, raising it to the 0 power makes it come back with 1. Alright, so let's maybe put some of these to the test here with some quick little examples, and I'm going to focus on the ones that may be a little bit more challenging here on this page. But I do want to start out with this guy and this guy, because the position of the parenthesis really matters here. This is why your calculator lies to you all the time. So if you were to type these into your calculator, number 2 and number 3, and you type them in exactly as you see them, you would get -9 for number 2 and +9 for number 3. Okay, so now why are you getting 2 different answers here when you know in your heart that, well, it's probably positive? Well, stop and think about that parenthesis right there. This parenthesis, and let me undo my erasing here, didn't mean to do that. Okay, so stop and think about this parenthesis right here. This means if the exponent on the outside, the thing I'm raising to the power, is negative. So a negative times a negative makes a positive, and that's why we've got a +9. Over here, I'm going to go ahead and do the exponent first, because that's what Aunt Sally would have us do in the order of ops, and then I'd get -9 for the result there. So that's a quick little tutorial and summary on the rules of exponents. Try some of these practice problems out. I guess on this page I want to focus on maybe number 7 to help the cause, so I'm going to zoom in on number 7 here, because number 7 kind of requires a special little technique. You've got a whole bunch of things that are going on in this particular problem, just a whole mess of stuff. You've got all sorts of D's and F's, which are things we want to avoid anyway. Chuckle, chuckle. So let me break this up into just the numbers first. A 12 over a 3. Okay, the D's, if I combine the D's, I have D to the 7th power, but I don't have any D's in my denominator, so I'm just going to put a 1 down there, because you can't really put a 0, otherwise the whole thing goes undefined, and now you've done it. And then we have an F upstairs and an F downstairs, but that F downstairs has a -1 exponent. So we're going to simplify these one at a time, and when we do this, you just take it one piece at a time, makes it so much easier. The 12 over the 3, of course that works out to be 4. D to the 7th over 1 just works out to be D to the 7th. Now, one thing you need to think about exponents is if you don't see one, you have to presume it's 1. So if I do 1 minus -1, well, why am I subtracting? Because very simply it's the quotient rule that's in action here. So 1 minus the -1 gives us a power of 2, and that power of 2 is going to be in the numerator. So it's 4d to the 7th and f squared. Okay, so let's go to the next page, and maybe we'll take a look at something else there that's kind of interesting. And as we go to this next page, I would like to just kind of focus in on number 14, because I think that's probably the problem that most people are going to not want to deal too much with. So let me get it over in a position where we can work on it here. Let's get it nice and big and in the picture. Okay, so the first thing I'm going to do is I'm going to notice I've got an outside exponent of 2. I'm just going to distribute that to everything that's on the inside, and I'm not even going to think twice about it. So 3 to the second power is 9. A to the negative third squared is going to be a to the negative sixth power. And then that's going to give me b to the 10th. And then downstairs I'm going to have 4 squared, which is 16. I'm going to have, let's see, 6 powers of a. And then I'm going to have negative 8 powers of b. Alright, so now what I'm going to do next is I'm going to sort this out piece by piece. And I'm just going to handle it one term at a time, starting with my numbers. And then my a's. And then my b's. So if you resolve this one piece at a time, it's going to make life a lot easier on you. Alright, so the 9 over the 16, there's really not a whole lot that you can do there. So they're relatively prime, nothing to cancel. For the a's, if we're going to follow the quotient rule, then it's going to be negative 6 minus 6 for an exponent of negative 12. Okay, so now what does that mean at that point? Well, my next line of work here, I've got a 9/16, and then I have an a to the negative 12. So I'm going to resolve that in a second. Let's go to the b's here. And if I do the quotient rule, again, if I do 10 minus the negative 8, that's going to give me an answer of 18. So I'm going to have b to the 18th. Alright, one last thing to deal with, and that's this wretched negative exponent, this misbehaving child. Now, this right here is the only item that's got a negative exponent on it. So the only things that you move up and down are just the ones with negative exponents. If you try to move anything else, you're just asking for trouble. So let's keep the 9 upstairs, and this b to the 18th, that's a positive exponent, so it's going to stay upstairs in the numerator. And then I have this 16 from the denominator, from the constants, and then this a to the negative 12th, that's got to come downstairs. So it's 9b to the 18th over 16a to the 12th, and that's where it ends right there. So there's your quick little tutorial into the world of exponents. Hope you enjoyed it. Try the practice problems and that are on this sheet, and then we'll go to the practice problems in the green packet.